Okay. All right, friends, welcome. This is the end of week 2. Can you believe it? We are already here. I can't believe you guys are halfway done with this stack. Can you imagine you have 2 more weeks and then you're done? Like done, which is crazy. Cool. Couple reminders. As always, you have core assignments. So your core assignments are arrays to do and strings to do 1. Now I know that you have your personal project. That's awesome. But don't forget to do this because they are important. We talked a little bit in office hour about strings to do. There was just sort of one question, and Edwin showed off his great code. So if you are looking, if you're a little stuck on strings to do, that's available for you. Don't forget you can concatenate strings. That's my one hint for you. I'll make sure that office hour is up and posted there too. And then you have your arrays to do. We've talked a lot about arrays, walking through that. So don't forget to do those. Next week, you do have a core assignment of solo project complete. This is you just submitting your your solo project. You also will have a group project proposal. I've gotten a couple emails from students, so that's awesome. In regards to, who they want in a group. Remember, tonight is the last night to tell me that you want to be in a group. Tomorrow morning, what I will be doing is I will be going in and, I will finalize the groups based off of the group preferences that you gave me. So if you haven't gotten a chance to do that, make sure that you fill this out. If you don't have a group, fill this out. And I can make sure tomorrow I will add you in a group. And it looks like perfect. We got 3 and 3, and I'll figure it out. That way it makes enough sense. You might have a group of 3 or 4. If you do have a group of 4, that's okay. I just ask that you do a little bit more advanced functionality. That's sort of the expectation there. 3 is plenty. But if you want to do 4, again, just tell me and kind of give me some of the, here's how advanced we'll do it. You can't do more than 4, so you can't have a group of 5 or anything like that. And 4 is really stretching it. So, but again, if you do want to be in a group, you have to email me and CC everybody. That's again, just to make sure that everybody knows that they're in a group with you and you're not just like claiming people. You're like, oh, they're smart. I'm in their group now. And then all of a sudden I do it and they're like, wait a second, I didn't agree to that. So it kind of creates that awkwardness, gets rid of that. Cool.
I have a question.
Yeah, go ahead.
So if we already have a group, do we have to add ourselves here?
Nope. Nope. You just have to add yourself here. If you don't have a group now, if you've already added yourself and you since then have told me, like I see a couple names that have already told me, I'll go through tomorrow and I'll make sure I've added in the groups that I know of. I think somebody else did just send me one. Groups that I know of as far, I got one more group to add in. So these are already some groups. There's no, group 1, group 2. There's no like, that's just the order in which people have told me, hey, I want to be in a group. So if you already have a group, again, I think Optimu, somebody did send me a message and I asked them to email me. I think it was Grant or Gage or something like that. But just make sure somebody emails me with everybody's email. Just again, so that way it's not awkward and that, but, and then, no, you don't have to put, if you're already in a group, you don't have to put it here. This is for people who are not currently in a group.
Okay, thanks.
Cool. Yeah, of course. Cool. Any questions regarding this? I will be making a page here in our classroom tomorrow that will have a sign up sheet. So basically what it will look like is there will be a Monday office hour and they're going to be in like little 10-minute segments. And so there's going to be 6 on Monday's office hour, 6 on Monday, or sorry, not Monday. Oh my gosh. Tuesday's office hour and then Tuesday's lecture, 6 in Wednesday's office hour, Wednesday's lecture, and then 6 in Thursday's office hour. And so if you don't sign up for that, that's okay. You just have to send me a video of you presenting your project that way. That's how we check solo projects. Obviously, we have the code to compare those, but you walking through, showing, improving, here's our CRUD, here's that. It's good practice to present and articulate your code, articulate the things that you struggled with. I'll send out a template next week on Monday, just kind of like some talking points so that way you guys have them, how to make it quick and efficient, answer these 3 things and you're, X amount of things, show us this, and then you're good to go. if you want to make a video, you can. Just make sure you present it in some sort of way, either with the class or with me. Again, if it's a 10-minute video or 5-minute video and you just go on Zoom yourself, you record, personal Zoom, record it, save it, send it, email it. That's fine with me. Totally up to you. Cool. One thing I also wanted to point out is on this day, it is Labor Day. So I will say Labor Day. And so this is a day off for everybody. It's just a national holiday. And so I will say, Coding Dojo. Okay. So that's Labor Day. Just wanted to let that out. You still have discussion questions due this week. They're still open for you. But just wanted to note that, there won't be anybody available, on 9/2 because that's Labor Day. And then this is the last week. Can you guys believe this is the last week of your entire Coding Dojo studenthood, I guess. After this, or next week, I will start sending out graduation details. Basically, we just kind of get together here, graduate, go through certificates. So I'll send out those details. You're welcome to invite anybody that you want. If you want, friends or family or whoever, doesn't matter. They're welcome to come in as long as obviously they stay on mute. Then that's okay. But they, if you guys should be very proud of this. So if you want to invite anybody, feel free to share those details there. And I might have like a specific link so that way we can, kind of make sure everything's in place. But I'll share that next week. Cool. Any questions on sort of the administrative stuff of what we talked about? Yeah, it is super exciting. Really coming up. You guys are almost there. Also, Crystal, let me know. I think it's Crystal. Can you put it in the chat? Sorry, I'm just putting you on blast, Crystal, but Crystal had a really great tool that she used yesterday for ATS, which is applicant sort of tracking within, it's called JobScan. If you guys want, you can look into something like this. If you didn't know, lots of companies use like an ATS scanner. It's really just AI to look through your resume. It gives it a score based off of, how your resume looks, how it's set up. And then it sort of will already, unfortunately, if your resume is not set up, it doesn't have the keywords, then it will oftentimes reject you and the recruiters don't even see it, right? Like nobody sees it. It just automatically like filters you out. So JobScan, this is something I don't work for it. I've never even used it, but Crystal was showing me that this is a cool way that you can kind of get your resume to make sure that you're passing through. And so if it goes through an ATS system, that doesn't automatically mean that you're going to get a call. But if it does, if the company uses an ATS system, then it will, at least you'll get through that. So it's a cool tool. I just want to share it because I think it's really neat. Cool. Great. So Charlie asked, are we presenting our solo project on Tuesday or Wednesday? It's going to be both days actually. And it's during the office hour as well. So it's 2 hours on Tuesday, 2 hours on Wednesday. And then we will likely have some solo project presentations for this office hour as well. So we're going to have 5 total hours of students. Now that is only, in theory, that's only 30 presentations, given that there's 6 per time. We'll see how long it takes. But if there's 42 people in here. So if you want to present to the class, make sure whenever I send out that sign up sheet that you go on and sign up. And again, if not, we can kind of work around it and you can send me a presentation. We can still do if you're like, I really am proud of this, I want to show it. I'm happy to still do it in office hour, like just a little one-off, like, hey, Taryn really wants to present this. So therefore, Taryn, we're going to give you 10 minutes and you present it during office hour here. So go ahead, Rumi.
I would rather just send a video to you from a Zoom that I record. Is there a sample, and I'm probably going to do it this weekend. Is there a sample presentation that we can look at just so that, because I'm
Great.
blind here?
Great question. I don't have one offhand. I'll see if I can find one, but what I will do is tomorrow I will create not a script, but just like, hey, here's what I'm going to be looking for, a guide to your presentation. It's really, it's pretty simple. It's, hey, you know, my name's Remy. What I worked on is X project. I use JavaScript for this. Here's all of my CRUD functionality. The idea is I can create a user and a user can create, you know, kind of giving us the layout. I sent you a form, you know, that you guys filled out that kind of asked a lot of questions. So it's kind of just filling that in. You know, I made sure that a user did this. I have validations here. And then at the end is like, typically I will ask like, hey, did you run into any hurdles and how'd you accomplish that? Or how'd you get around it? Or are they still there? Right. So you could say something like, yeah, and I wanted to do this, but I ran into a hurdle. So, you know, right now this is how it works, but in the future, this is what I'm planning on implementing. So I'll make sure I send out a script, if you will, on kind of the key pieces, and see if that helps.
Okay. All right. Thank you.
Yeah, my pleasure. Go ahead, Charlie. Is it Charlie?
Yes, it is.
Dope. Okay, go ahead.
Yeah, the last thing about the solo project, I see how the core assignment for solo project is due on Monday.
Mhm.
For that one, is that, you know, just only it's actually due on that day, like we can't turn it in later?
Let's check. It is due at well, technically you can turn it in on Sunday, by Sunday
Oh,
is your technical. I would encourage you to get it done because we're doing presentations,
yeah,
but
that's
from a compliance perspective, technically anything week 3 is due 11:59 p.m. on Sunday of that
Thanks.
week.
okay.
So yeah,
Thank you.
yeah, of course. But you do, and one thing I will say, you have to have a solo project and a group project complete in order to pass the class. So just throwing that out there. Yeah, they both have to be complete. So. And the last thing I would say is anytime that you're working in your solo project, like if you guys were to extend it to week 3, that is time you're taking from your group project. So we want to make sure, and if you know, if at the end of the day, not trying to be a jerk, but that if people take all the way up to week 3, and then all of a sudden we are presenting your group project presentations at the end of the week, and we'll kind of probably add in another day here, and you've only worked on it for a day or two, then then it gets into the issue of did people even participate, and then therefore credit and all that stuff. And remember, you have to have both. So my biggest encouragement, just turn it in by this Sunday, but technically you're right. You don't have to do it until next Sunday. Cool. Any other questions? Okay. Okay. Well, I wanted to talk about what we did yesterday. We talked about a lot of things. We did a lot of things. So I wanted to make sure that people really understand what we did, how we built it, and kind of walking through some logic there. So yesterday, we sort of built on what we did on Monday, or sorry, Tuesday. My days have been wildly off. On Tuesday, we built a node, right? A class of a node, and it had a constructor, which actually is what builds our node. And we have 2 attributes of that. We have some data, and then we have a .next attribute as well. This is what helps us understand this .next is really called what? What part of that is my single linked list of that? Does anybody know? There's a key. Go ahead. .next is what in return in relation to my node?
The next node.
The next node, but what is the .next attribute itself called? There's a key word I'm looking for. Starts with a P.
Pointer?
Yeah, exactly. It's your pointer, right? It is what's pointing. This is what Habtami was saying. But I just wanted the word pointer. It is pointing to the next node, right? And so that is what dictates the path of my singly linked list, right? Wherever it's pointing to next, that's where, that's the next node. And that next node is going to have a pointer. And if it's null, that means it's the end of my singly linked list. And if it's got a new value, then that just means that it's, we still are going. We're still continuing there. So that's just my node itself. Now, a singly linked list is a data structure that is consistent or that consists of nodes themselves. And so all a singly linked list has in this case is a head, right? And if we were to go to the platform and look at that, there's a great little image of a train. When we're talking about a linked list, that talks about sort of, it's the beginning, it's the head. The head is always the front of my singly linked list. Cool. That's all it has. That's all we need, right? We created this method called add node here, where we are starting to add or starting to build our singly linked lists. And what we do is we just create some arbitrary number. This could be called unicorn if we wanted. It doesn't matter. We called it new node. It could be called anything. It's just a variable. But its value is a new instance of my node class, right? Given the value that we passed in. So whenever we built it, we passed in the number 11. It was creating a new instance of my node that had a data of 11 and a property of .next that is by default equal to null, right? And so what we first checked was, is this singly linked list empty? If it is, well, then let's go ahead and make this the head. I know this was a point of confusion, so I want to make sure that everybody understands this. If the singly linked list is empty, well, let's make this the head. And now my singly linked list just has one value in there, right? It's the node of 11. Else means that it isn't empty, right? There's already a value at the dot ahead. Could be 11, could be, whatever it is. There's already a value and says, okay, great. There's already a value. I don't need to make this the head, but now I need to go and iterate through the entire list to make sure I'm adding it to the end, right? And this whole point is we want to add to the end. So we can't just immediately say, well, the head needs to now point it to this node, because then it breaks our chain. It breaks our linked list, and we don't know, well, what's the next pointer, right? And so what we do is we say, okay, well, let's grab the current node, and we're going to start at the beginning, and we're going to iterate through. So when we start at the beginning, we're going to start at this dot head. It's the same way that when I say let I equals 0, and we're dealing with array dot length, right? We're just starting at the beginning. And then I say, while current node dot next does not equal null. If it equals null, that tells me that the value or the current node that I have doesn't have anything after it, right? Because if the dot next equals null, that means that it's not pointing to anything. So we can assume that that's the end of my singly linked list. If it does not equal null, meaning that there's some value coming after it, well, then let's just move my node and go from 11 to whatever the dot next is. So we're just going to move on to the next node. And then it's going to check and say, well, does this next node's dot next, does that equal null? And if it doesn't, well, then it just keeps on going until it finds the node whose property of dot next is equal to null. And then once it finds it, right? Once it finds the node with the property of dot next that is equal to null, it exits my while loop. And then now we assign and say, okay, now I want this dot next property, which is currently equal to null, to point to my new node. i.e. we are adding it at the end of my singly linked list. I'm going to pause there. Does that make sense? Are there any questions on us adding to the end of a singly linked list? Or put a 1 in the chat if this is all making sense. You guys know exactly what we're doing.
I have a question.
Yeah, go ahead.
On line number 15, the if condition body, this dot head equal null, and if not this dot head are the same thing, like the way this is another way saying the line number 15 is if not
Is that in Python or is that in
Java,
Python? I think you say if not this dot head, which would
like
then
negation or something
yeah,
like
I think in
it's
Python you could say if not, but with JavaScript we say it like this.
I think in JavaScript you can do the same thing, like exclamation, like not means exclamation,
Oh, if, yeah, not this dot head like that.
space. Yes, that's the same thing.
Let's try it. Let's just run it and see if it gives us an error. Yeah, I think this would work, right? Because it's just saying, hey, this is not, there's no value there. Now, the only thing I would be curious on is if this is going to default to null or if it's saying that there's no value, but let's try it. Yep, so that worked just fine. This is
Okay.
another way to say it.
Oh, okay, okay.
Yeah,
Thank you.
good point out. Yeah. I'm gonna keep it this way because it's a little bit easier to read. But yeah, that would work just fine. Good point out. I always love to, we make it work and then we can improve it. That I would say that that's an improvement to the code. I'm gonna keep this here because it makes, for those that are learning, it's a little bit more sense, but Hoptamu, I think that's a great point. Any other questions on this? I don't see any ones in the chat, so are people stuck on this? If you are, please speak up because I want to make sure that you really understand what's going on here.
I'm sorry, again, another question, like, on this class method, add node to front, are we returning anything like, for if this dot head equal null and this dot head equals new node, are we returning this? Like, do we have to return something?
Hold on one second. Can you ask that one more time?
So this class method add node to the front. I don't see there's return. Do we need to return something like for, let's say for if this dot head line number 15?
Nope.
Mhm.
Nope, we don't need to return anything here. This is just a built-in method within my class here.
So
nope,
where is the return then, like for this method?
I'm sorry.
How do we return? Like how do we?
We can still return. We can still return things, but we don't need to because it's dealing with this. Remember, it's just dealing with the instance. So here we have an instance of singly. And so
Oh.
it automatically is dealing with that instance. And we don't have a database or anything, so it's not persistent. But it's just dealing with this instance of a singly linked list. So that's why the keyword of this is referring to singly in this case.
Okay.
Remy, I see that ChatGPT is a great tool, but I'm here now and we sort of have this extra lecture to really hash this out. So I see that you said you're too confused to know what to ask. Let's just kind of piece it together. Do you understand what we did here with building a node class? We're just saving some data.
Yes.
Cool. And we understand our singly linked list, we're just creating a structure, but it's just an empty. It's in the same way that if I were to say, let me do this in office hour because it makes it a little bit easier. If I were to say, let X equal this, well, there's nothing in my array, but I'm just saying, hey, I want you to save some value and it's going to be an array.
Mm-hmm.
Cool. So here, what part of it, if we could start from the top line,
Mm-hmm.
what part of it isn't, or is there some confusion?
So this third chunk is where I'm generally confused.
Okay.
I understand the class, I understand building the structure that holds data,
Mhm.
but it's the movement and the if else and
Yeah.
the chart where it like grabs things and then points. I don't get it.
Yeah. Great. All right, let's do this. Does anybody else, let me ask it, does anybody else feel this way?
I'm
Yes.
cool to do ChatGPT if everybody else is like, I got this.
Well, nobody else, only one person says looks good, so, okay, Crystal says you're like halfway there, PJ, Jacob,
I feel like maybe
Jarrell.
having you explain it maybe one more time might be
Yeah,
a
you
little
got it.
more helpful than just going straight to the computer, but
Yeah,
yeah,
for
whatever
sure.
works.
Let's do it in a way that maybe I'm gonna do it in a way that maybe you'll understand a little bit better. Well, let's deal with an array. So let's just build this entire thing out as we'll like see the process of it as we would if we were dealing with an array. Cool. So I am going to, let's make this full screen. I am going to that, get rid of this. This is going to come here. Okay. This section is us doing this. Right? We are defining, I want to build an array. I'm going to say class SLL equals defining the data structure. Structure, structure without data in it. Okay. Now, when we're dealing with this add node, let's kind of break down each portion and deal with this. Now, when I say let new node equal node value, all I'm doing is I'm creating an instance of my node. It's the same way that if I were to say let y equal 1, right? Yes, I've got a class, but I think we know how to do a class, and we're just creating an instance. And all this is, if I were to print or console log new node, it's just going to show me that node, right? So all this line is doing is this is actually now giving, we're creating a new variable called node, and it's giving it some sort of value. In this case, it's an instance of my node, but on the right here, we're just going to put it's going to be equal to 1. Cool. Now, what this is doing is it's checking and saying if this dot head is equal to null. What we're doing is we're checking, is my singly linked list empty? It would be the same thing if I were to say if x dot length is equal to 0. Right? If x dot length is equal to 0, what does that tell me about my array?
That it doesn't hold any data.
Exactly, right? That it's empty, right? There's absolutely nothing in there. And so then we're saying, well, okay, if it's empty, well, then I want to add this value at the beginning. So how would I do that with an array? How would I just add it to, how would I add y to an array?
X dot push.
Exactly. Let's say
y.
x dot push y. Right? And so now if I were to console log x, I will see 1, because that's now at the beginning. So all this is saying is, hey, if the singly linked list is empty, let's just add this value to the front. We call the front the head, but they're doing the same thing, right? We're just adding it here. If it's not empty, well, then I need to find the end, right? Now, it's a little bit different than an array because push automatically goes to the end. So that's kind of a built-in function. But let's say I wanted to do something like I wanted to iterate through and find the very last value. If I need to iterate through my entire array, how would I do that?
While loop.
Yeah, or if I'm doing with an
Length
array,
minus 1. Length
Yeah.
minus 1.
you could do a length minus 1, but more so I'm saying we have to do a for loop. So we can't use some of the built-in arrays, but we have to do a for loop. If I want to go through the entire array, I would say for let I equal 0. I is less than x dot length I plus plus, right? And this is going to go through my entire for loop.
And that's the same thing as the top where it's this dot next, right? Keeps going this dot next until it's null.
Exactly, exactly.
Wait,
So
say
the
that
only,
one more time.
so right here, I am gonna iterate through the entire array. Right? And at the end, once I'm at the end, I could say, you know, if I, or sorry, I equals x dot length minus 1, oops, oh, sorry, x of x dot length minus 1. And what does this tell me? X of x dot length minus 1, what does that tell me?
The last element.
This is the last element. So I'm saying, hey, if I'm at the end, then I'm just gonna write this, I'm gonna add new value here. Remember,
think-
x dot length gets me it's however many values are in there. A key or a secret that we can do is we could say x dot length minus 1 is gonna get me the index position of the last value.
I think that's makes more sense if you relate to the first single list and node list, like for loop line number 12 with while loop on line number 19 to the other function. Just
Yeah.
to,
Yeah, so yeah, give me just 1 second. So we're saying, okay, if I, it's not even x of, is equal to this, x dot length minus 1. Meaning that I know that x dot length minus 1 is going to give me the last index position of my array. This is just telling me, am I at the end of my array? Right? Well, this is, then maybe I want some functionality that I want to add in a new value here. I just iterated through the entire thing. I found the end, and now let's add in our value. In this case, you know, add new value here. Yeah, I think that's fine. What this is doing is this, because we don't know how large a singly linked list is, what's nice about an array is we can do a dot length and we know how long it is, right? That's one of the powers of an array, right? It's sort of fixed and we could do the x dot length or array dot length, and we can quickly see how many items are in there. We can't do that. We don't have those properties with a singly linked list. So what we do instead is we use a while loop, because it could be, you know, 3 values. It could be 3 million values. And what it's saying is it's checking the current node's property. So we're starting at the beginning, just like we did with 0 here. And each node has 2 pieces of information. It has the actual value itself, or the data is what we called it. And then it's got the pointer to, hey, I'm pointing to another one. So we're checking and saying, hey, this or current node is we're gonna start at the beginning, just like when we say for let I equal 0. I could be anything, but we're saying 0 because we want to start at the beginning. And now we're checking and saying, well, hey, is the current node, which we have right here, which is our head at the beginning, it's got 2 properties. It's got the data and the dot next. Does the dot next point to anything? So if it doesn't point to anything, then this is not true, right? Because if it points to nothing, then the current node dot next value is null. So if we're at the end, the current node dot next value is going to equal null. But if it does point to something, we enter our while loop, and this is the very beginning. We enter our while loop, and then we say, okay, well, we know that my current node is pointing to another node, right? To my next node. If I've got, in this case, I've got 11 points to 1, right? And so I say, well, then 11, my first node, is not the end. So let's just move on to the next node and see if it points to anything. So I say current node equals current node dot next. So I'm redefining my variable here. And then it's going to say, okay, now I'm on the next node. That next node has 2 properties. It's got a data property and it's got a next property, is the next property null? Or is it pointing to something else? If it's pointing to something else, well, then we enter in and say, well, this can't be the end, or we are still in our while loop. Well, this isn't the end. Let me move to the next one. Remy, I see your hand up. Go ahead.
Yeah, can we go back just a couple lines? I'm a little bit lost from the right to the left side. Because like I can see how things match up
Mhm.
until we get to the for loop on line 12.
Yeah.
I don't see where the for loop exists in the left side. Cause
Right
I see
here.
this going to the. So
So-
why did you call the for loop on the right and a while loop on the left?
We use a for loop with an array. You can use a while loop if you wanted, but we use a for loop because we know how long a for loop is. Because it has a built-in property called length.
Uh-huh.
Arrays have a built-in property called length that tells us how many items it are, so we can say, hey, I just want you to go through the entire thing. With a singly linked list, we don't have said property. We don't know how large it is, so we have to just iterate through the entire thing until we find the node whose dot next value is equal to null, and that's what tells us we're at our end.
Oh, I see. Okay, that
Yeah.
makes sense.
Yeah, so here we know x dot length, as long as I is less than that, or once it gets to whatever the length is, then we've gone through the entire thing.
Mhm.
We don't have that property, so we have to use a while loop here.
Okay, I get it.
This line 18 is us doing the same thing as us starting I at 0. So we're
Okay,
just starting at the beginning.
okay, thank you.
Yeah, does that make more sense?
It does.
And then we're just going to keep iterating through until we do find the node who does have a data value, but their next property is equal to null. And we say, aha, we are at the end. And now we say, well, now that we're at the end, we found the last value. I don't want their dot next property to equal null. I want it to point to the new node that I just created. So then now we just say dot next equal new node. And then we have added that to the end. And now it points to my new node. And so if I were to add another one, it's going to do the same thing. And the last property will be my, whatever my, most recent new node was. And then it's, then it just keeps pointing to the new value. So at the beginning, we check. So when we actually ran this, add node, it first checked. We created a singly linked list called singly. We ran the add node, passed in 11. It created a new node with a property of 11. So it had a dot data of 11 and a dot next of null, because that's by default. It checked and said, hey, is there anything in the head? Well, there's not, right? Because this is the first value. So then it just made our 11 our head. Well, then when we added the 1, it's going to say, is there a head? Well, yeah, there is, because 11 just did that. So then it's going to say, is 11's dot next property equal to null? Okay, well, it is equal to null because there was only one in there, and by default, a node's dot next property is null. We say, cool, let's redefine that, and 11's dot next property is now equal to the new node I just created, which was our 1. Then when we come to 7, it's going to check, hey, does it have a head? It does. And then it's going to say, okay, start here. Is its dot next property equal to null? Well, it's not, because it points to 1. So it's going to say, okay, well, then let's go to 1. Is its dot next property equal to null? Well, it is, right? Because all we have is 11 and 1. It's going to say, cool. Now, instead of it being null, have it point to 7. And then we just keep doing that over and over and over again. How is that feeling for everybody? I see processing, struggling. Habtamu, Jarell, Jasmine, is this making more sense? Did the array, sort of seeing how we would do it with an array, did that help, or did that make it a little bit more confusing?
Yeah, it definitely helped. Will, could you maybe just go over again? I know we've talked about this a couple times, but why somebody would use this over an array, like what the benefits of it. I know we used like Pandora as an example, but it seems like, the array is a lot. I guess if you like, when would we use the singly linked list in the real world situations? What the benefit is?
Yeah. So when we're dealing with, there's a couple different, great question, Austin. when we're dealing with like music, that's a really big one because you can make playlists, and instead of recreating sort of like, okay, this playlist, I'm gonna create this playlist that has all of these songs, and then I'm gonna create this playlist, and there's some kind of like kind of the same songs are on multiple playlists. You can just create a pointer, you create the song, and you create a pointer to that song. Think about it this way. We, at the beginning of the office hour, we're talking about setting up tables, right? And sort of the power behind object-oriented programming is that we can create an instance of Yarn. I think Taryn was talking about Yarn, or somebody was talking about Yarn. And we can create an instance of Yarn, and instead of having multiple instances of Yarn, right, or multiple of the same instance, maybe, red yarn 10 times, I can just get red yarn once, and then I can add that in, and I can use that unique identifier on multiple tables, right? If I got a pattern, I could just say, hey, the ID of whatever the instance of red yarn is. Same sort of idea here. Instead of me having to create an array that has a list of songs and then another list of a lot of the same songs, I could just point to all of those songs and just change my pointer. So now I don't take up as much space in memory. That's really kind of the biggest power. Arrays are wildly popular. I'm not saying, and what I want to be very clear is, one data structure, like a single linked list, is not more powerful than an array. Arrays are one of the most powerful. It just isn't always the most optimal. And so that's why we have so many types of data structures, because you can use the same. I mean, could you figure out a way to use an array instead of a single linked list? Sure. It might not be the most optimal, but we can, right? And so, but maybe memory is a big issue for us and we don't have just unlimited space. Well, then we might go to something like a single linked list because it is much more efficient when it comes to memory.
Okay, yeah, thanks. That helps a lot. It makes a lot more sense. Your pointer example, I understand now.
Yeah, good. Go ahead, Taryn.
So for changing the pointer, is there a way that we do that explicitly, or is that more in like from lines like 64 to 67, you're typing it in a different order, adding nodes in a different order?
So we could change it. And we do that here. So when we are even removing from the front, all we do is we're changing, if we're dealing with a pointer, whether we want it to point to something else or we want it to stop pointing to something, all we're doing is we're finding the node we want to affect, right? The node before, and we want it to point to something else. And all we're doing is updating the this.next property. So if I want it to point to something else, I just update that property here.
Okay.
So it's not anything that's happening, like we don't have to deal with the memory portion. When we say this dot next and we give it a node, each node has a memory space. Did you take Python perchance?
It was several months ago at this
Long
point.
time ago. Well, in Python, there's this really annoying thing when we deal with a class, and or an object, especially from like a database, and we would, try to retrieve that object and print out that object. And instead of it giving us, the information we want that looks like a dictionary, it would just give us some weird object number, right? And it would say like, it was just its place in memory of where that object is. Same sort of idea. The computer saves it and saves different properties associated with this. So when we're dealing with a pointer, we don't have to say like, oh, it's over here in memory. We just say, well, this node, and the computer goes, okay, that node, I stored it here, right? In this place in memory, and place 1, 2, 3, right? And so then it does that for us. But we can affect and change pointers as much as we want, all by just changing the this.next property of that specific node. So if I wanted, if I wanted 1 to point to 8 instead of 7, I would just go in and I would basically, what I could do is say, hey, let's iterate through, let's find the 1, and then its dot next value, or I would iterate through the entire thing maybe, and then I could say its dot next value is going to be equal to, and I find 8, and I point to there, and I say, well, 8's dot next value is now 7, right? And so I'm just changing the dot next values in the same way that I'm just kind of erasing an arrow and pointing it to 8, and now 8 points to 7. I could do that.
Gotcha. Thank you.
Yeah, of course. Any questions?
I'm sorry, like, if, I don't know, I haven't heard, can you give us a real world example? People use a single list.
Yeah,
Just a-
I've given you guys a few, so I don't want to spend too much more time on it, but Pandora, Spotify, any sort of music would be Pandora probably is the best one because you can't go backwards. Next week we'll talk about a doubly linked list, and that's where we can go back, right? And so we have really all a doubly linked list is our nodes not only have a dot next, but they've got like a this dot prev.
Oh,
And
Well-
it's gonna be equal to, so at the beginning, it's gonna be equal to null. And instead, of us just saying, okay, well, the dot next value is equal to this, maybe whenever I create a new node, I'm gonna say, well, the previous node is equal to this dot head. So if I'm saying like maybe my second one, the previous is equal to this dot head, the next is equal to null, and I still have my data. And so now I can go back and forth, right? Because I can say, well, go to this dot previous, and then it can go back. And if I say this dot next, then I can go forward. And so that's really all a doubly linked list is we have this right here. We have this dot prev. And now I can go back because I can go to the first one, and then that one I can say, well, go to its previous, and then go to its previous, and then go to its previous, and then we're there.
thank you.
And I believe a doubly linked list also has a this dot tail. That would be a doubly linked list. And that's just the end of it. And then we could do it to where the tail points to the head, and that's a circular list. Think about like repeat for songs. If I want an album on repeat, so I can listen to a song till my ears bleed.
Like shuffle.
Shuffle would be different. Shuffle would be you could repeat shuffle, if you will. Like it might randomize songs and it points to all the different ones, and that the last song is going to automatically go to the first song. That would be a circular one. But shuffle would just be a randomization, but you're still just using a doubly linked list because you're shuffling them, and then they're pointing, and they point to the previous song and the next song.
Okay.
Any other questions on this? I know we sort of spent the entire class, but I really wanted to make sure you guys understood a singly linked list and how they work.
Can we say like this single list, double link, queue are these are advanced data structure?
I wouldn't say they're advanced, but they are the base data structures. Like, and when I say advanced, I mean, there's really just different categories. It's not like one's more advanced than the other. There's advanced things that we can do, like breadth first search and depth first search, and, dealing with some, different algorithms. But at the end of the day, there's sort of just base data structures that we kind of walk through here, where you get singly linked lists. We're going to talk about recursion. Recursion's a fun one to do, but it's also kind of confusing at the beginning. But then, like I said, you've got trees. Again, it's just a descriptor of this type of data structure. Again, trees are not better or worse. They have their place in the same way that singly linked lists or a queue and a stack do. Here's the doubly linked lists. Yeah. You've got sorting. So this is like if you want to sort things, that is its own time and space complexity. Sets, multi-sets, there's hash maps, there's lots of different types, hashes. There's lots of different types. So it's just a type in the same way that, I guess a way to think about it would be like a variable. You could be a string, you could be a Boolean, you could be undefined, you could be a number, you could be a float maybe, right? Those are all just different types, and they all have their place. So whenever you want to represent a decimal, you're going to use this float. Or you want to represent a string, I could put a number in a string, but that might not be the most optimal. I might need it as a number, right? And so same sort of idea. It's just a data structure within coding itself. Cool. We got 4 minutes left. Are there any other questions on singly linked lists, what we did, walking through kind of how we did everything? Okay. Well, that's all I have for you guys tonight. Just kind of wanted to go through this, make sure you guys all understood it. I will be, like I said, tomorrow, I will be putting you all in groups. So if you haven't gotten the chance and you don't have a group, please make sure you put your group project preferences. If you do have a group, but your group has not emailed me and or you've not been CC'd on anything, please make sure that you go through and email me that immediately, or else tomorrow when I put in groups, that's kind of the final, that's your group, right? Because I can't just keep going back and forth. Well, I wanted to work with this person. If that's the case, please do that ahead of time, because once I put you in groups, that's your group. So any other questions, my friends?
Oh, thanks a lot, Will. Appreciate
Yeah,
it.
of course. Have such a good weekend, everybody. Great job. Keep working on your solo projects. And we will see you on Monday or Tuesday. Oh my gosh, my days are all mixed up. Bye, everybody.